September 12, 1944. Near Ericourt, Lorraine region, eastern France. 14:27 hours. The afternoon sun hung low over the rolling farmland, casting long shadows across fields where unharvested wheat still stood in ragged clusters, trampled by the passage of armies. Oberfeldwebel Karl Brenner sat in the commander's cupola of his Panther Aus G, scanning the horizon through Zeiss optics that represented the finest precision engineering German industry could produce. His tank, 73 tons of sloped armor and high-velocity firepower, sat hull down behind a gentle ridge, only the turret exposed, positioned exactly as doctrine prescribed for ambush tactics. Behind him, for more Panthers occupied similar positions, spaced at 50-meter intervals to provide overlapping fields of fire. They had been waiting for 2 hours, engines idling, ammunition ready, confident in the calculus of armored warfare that had served them since Kursk. Karl had learned to trust his Panther. Its 75mm KWK 42L/70 gun could penetrate any American tank at ranges exceeding 2,000 meters. Its frontal armor, 80mm of sloped steel on the glacis plate, 100mm on the turret mantlet, had been proven against American 75mm Sherman fire repeatedly. The mathematics were simple and brutal. German tanks could kill American tanks from distances where American guns couldn't penetrate German armor. This was a tactical reality that had allowed outnumbered panzer units to inflict disproportionate casualties throughout the summer of 1944. Karl's crew had destroyed 6 American tanks since Normandy. They had survived because their armor protected them while their gun reached out and killed with impunity. The Panther wasn't just a weapon. It was a guarantee written in steel and ballistics that skill and engineering could offset numerical inferiority. At 1,429 hours, Karl spotted movement 3 kilometers distant, a column of American armor advancing along the road that paralleled the Moselle River. He counted 7 Shermans, the familiar silhouettes of M4A1 models with their rounded turrets and short-barreled 75mm guns, standard equipment for American armored divisions, and standard targets for Panther crews who understood the engagement envelope. Karl ordered his gun to track the lead tank, waiting for the Americans to close to 1,500 meters, close enough for guaranteed first-round hits, far enough that return fire would be ineffective. The waiting was professional, patient, backed by 2 years of tactical doctrine that said American Shermans were mobile coffins whose only advantage was numbers, and numbers didn't matter when you could kill them from beyond their effective range. Then, at 1,431 hours, the lead Sherman fired, not at Karl's position. The American tank hadn't spotted his carefully camouflaged Panther, but at a German self-propelled gun position 500 meters to Karl's right. The report was sharp, distinctive, but wrong. The muzzle flash was brighter than standard 75mm fire, and the crack of the shell passing through air carried a different pitch. Higher, faster, the sound of something moving with velocity that shouldn't be possible from a Sherman's gun. Karl watched through his optics as the German Stu-G3, positioned behind cover that should have protected it, was struck squarely on the frontal armor. There was a sound like a hammer hitting an anvil, then the catastrophic secondary explosion as ammunition ignited. The Stu-G's crew had no time to bail out. In 3 seconds, a fighting vehicle crewed by men Karl had shared coffee with that morning ceased to exist. Karl's gunner had the lead Sherman in his sights, range estimated at 1,400 meters. Karl gave the order to fire. The Panther's gun spoke with the deep authority of German engineering, sending an armor-piercing cap ballistic cap round downrange at 925 meters per second. Through his optics, Karl watched the tracer arc toward the Sherman and strike at an oblique angle on the turret face, the round deflecting upward in a shower of sparks without penetrating. The Sherman's commander apparently saw the muzzle flash, because the American tank's turret traversed with hydraulic speed, and at 1,432 hours, it fired again, this time at Karl's Panther. The round hit the glacis plate 6 inches right of center. Karl felt the impact through the tank's entire structure, not the glancing blow of a deflected round, but the solid strike of penetration. There was a flash of white-hot metal as the projectile punched through 80mm of sloped armor that was supposed to be proof against any American tank gun. The round didn't detonate. It was a kinetic penetrator, not explosive, but it turned the interior of the fighting compartment into a storm of spalling armor fragments traveling at supersonic speeds. Carl's loader died instantly, his chest opened by a fist-sized piece of his own tank's armor. The radio operator screamed once, then fell silent, and Carl Brenner, veteran of 37 tank engagements, survivor Kursk and the Falaise Pocket, found himself staring at a hole in his supposedly impenetrable armor, punched through from 1,400 meters by a Sherman tank that wasn't supposed to be capable of threatening a Panther at any range. This is a story of how American HVAP ammunition, high-velocity armor-piercing rounds, shattered not just Panther armor, but the doctrinal certainty that had sustained German tank crews through 2 years of defensive warfare. It is a tale written in tungsten carbide and desperation, recorded in the panic radio transmissions of Panzer commanders who discovered that American innovation had closed the technological gap they relied upon for survival. It is an account of how industrial capacity combined with metallurgical engineering to transform the Sherman from a tank German crews had learned to disdain into a weapon that could kill Panthers from ranges where Panthers had believed themselves invulnerable, and how that transformation destroyed the psychological foundations that kept German armor crews fighting against impossible odds. The Panther tank, designated Panzerkampfwagen V, was Germany's answer to the Soviet T-34, a medium tank that combined thick, sloped armor with a high-velocity gun capable of defeating any Allied armor. Introduced in 1943, it represented the apex of German tank design philosophy: superior optics, superior armor metallurgy, superior gun performance, all combined in a platform that could dominate armor engagements through technological excellence. By late 1944, the Panther was the backbone of German armored forces in the West, deployed in independent battalions that served as fire brigades, rushed to crisis points to blunt American and British advances through superior firepower. The mathematics of Panther survivability were well documented. Its 75mm KWK-42 gun could penetrate 150mm of armor at 1,000 meters, sufficient to kill any Allied tank frontally at combat ranges. Its own frontal armor, sloped at 55 degrees, provided effective thickness exceeding 140mm against typical engagement angles. American 75mm tank guns, standard armament on most Shermans through mid-1944, could not penetrate Panther frontal armor at any practical range. Even the British 17-pounder gun required shots under 500 meters to guarantee penetration. The Panther can engage Allied tanks at ranges where those Allied tanks pose no threat, creating a tactical advantage that allowed small numbers of Panthers to devastate larger Allied formations. German tank crews were trained to exploit this advantage ruthlessly. Doctrine emphasized long-range gunnery, using superior optics to identify targets at distances exceeding 2 kilometers, then engaging systematically from hull-down positions that exposed only the heavily armored turret. A properly employed Panther platoon could command approaches across 2,000 meters of terrain, destroying any Allied armor that attempted to advance within that envelope. American tankers learned through bitter experience that attacking across open ground against positioned Panthers was suicide. Loss rates in some engagements exceeded 70% for attacking Sherman units. But the advantage wasn't just ballistic. It was psychological. German tank commanders had internalized their superiority through repeated validation. They had survived engagements where American tanks burned before getting close enough to threaten them. They trusted their armor because their armor had kept them alive through situations where lesser vehicles would have been destroyed. This confidence wasn't arrogance. It was rational assessment based on empirical evidence. Panthers could kill Shermans at ranges where Shermans couldn't kill Panthers. Therefore, following proper doctrine meant survival. The equation was simple, proven, and had become the foundation of how German armor crews understood their role in defensive warfare. American tank crews understood the same equation from the opposite perspective. Sherman tanks in 1944 were reliable, mechanically sound, and produced in numbers that German industry couldn't match, but they were outgunned and underarmored relative to German medium and heavy tanks. The standard M4 Sherman with 75mm gun could not frontally penetrate a Panther at any range. Even the upgunned M4A3 with a 76mm M1A1 gun Introduced in summer 1944, struggled against Panther frontal armor with standard ammunition. American tankers developed tactics to compensate, use superior numbers to flank German armor, use mobility to get side shots, use artillery and air support to suppress enemy tanks. But these were tactics of the weak attempting to overcome the strong, and everyone knew it. Sherman crews had a grim saying, "It takes 5 Shermans to kill a Panther, 1 to draw fire while the other 4 flank." The joke was that the first Sherman's crew never got the chance to find out if it worked. Into this tactical reality, American ordnance engineers introduced the T4 high-velocity armor-piercing round, universally called HVAP by the crews who would eventually fire it. Developed from captured German technology and British research into tungsten core ammunition, HVAP represented a fundamental advance in penetrator design. Where standard armor-piercing rounds relied on hardened steel projectiles, HVAP used a tungsten carbide core, a material significantly denser and harder than steel, surrounded by a light aluminum sabot that fell away after leaving the barrel. The tungsten core, traveling at velocities approaching 1,200 meters per second from the 76mm gun, concentrated enormous kinetic energy on a small impact point, allowing it to punch through armor that would deflect conventional rounds. The ballistic performance was transformative. Standard M62 armor-piercing shot from the 76mm Sherman gun could penetrate approximately 110 millimeters of armor at 500 meters, insufficient to reliably defeat Panther frontal armor. The T4 HVAP round could penetrate 157 millimeters at the same range and approximately 135 millimeters at 1,000 meters. For the first time, American tank crews had ammunition that could frontally defeat a Panther at combat ranges, transforming the tactical equation from one-sided slaughter into viable engagement. But HVAP had a critical limitation: tungsten scarcity. Tungsten carbide required tungsten ore, a strategic material needed for machine tool bits, armor-piercing ammunition, and high-temperature applications across American industry. Production bottlenecks meant HVAP rounds were manufactured in limited quantities and rationed carefully. Through late summer and early autumn 1944, HVAP was issued sparingly, often just 3 to 5 rounds per tank, reserved for critical engagements against heavy German armor. Standard doctrine was to use HVAP only when facing Panthers or Tigers, conserving the precious ammunition for situations where nothing else would suffice. This scarcity meant that German armor crews encountered HVAP irregularly through August and early September 1944. Some Panther crews were destroyed by HVAP without understanding what killed them. The tungsten rounds left distinctive penetration signatures, but surviving witnesses were rare. Other crews reported being engaged by Shermans at ranges where penetration shouldn't be possible, but attributed these incidents to lucky shots hitting weak points. German intelligence collected reports of a new American ammunition, but lacked captured samples for analysis. The full implications of HVAP weren't understood by Wehrmacht tank commanders until American production increased in late September, and HVAP-equipped Shermans began appearing in numbers sufficient to change the character of armored engagements. The Battle of Ericourt, fought between September 18th and 29th, 1944, became the crucible where VAP's tactical impact crystallized. German forces launched a major counterattack aimed at driving the U.S. Third Army back from Lorraine and potentially encircling American spearheads. The attack committed substantial German armor, 5 Panzer brigades with over 200 Panthers and Panzer IVs, against the 4th Armored Division, an American unit equipped with approximately 180 tanks, including a significant number of newly arrived M4A3 76, W. Shermans armed with 76mm guns and supplied with HVAP ammunition. German commanders planned the attack with confidence, grounded in their experience of armor combat. Their Panthers outgunned American tanks. Their crews were veterans of the Eastern and Western fronts. Weather conditions, heavy rain and fog, would limit American air support, neutralizing one of the Americans' key advantages. The terrain around Ericourt offered good tank country with rolling hills that provided hull-down positions and sight lines exceeding 2 kilometers. By every reasonable assessment, German armor should have achieved local superiority despite numerical parity, bleeding the Americans through superior long-range gunnery until the American advance stalled. The engagement that unfolded confounded these expectations. American Sherman units, particularly those equipped with 76mm guns and HVAP ammunition, engaged German Panthers at ranges exceeding 1,000 meters and achieved penetrations. German tank commanders, accustomed to frontal immunity at these distances, discovered their armor was failing against hits that shouldn't be threatening. The psychological impact was immediate and devastating. Panthers that had survived dozens of engagements through protective value of their armor were being knocked out by single shots from tanks they'd been trained to consider inferior. The engagement that unfolded confounded these expectations. American Sherman units, particularly those equipped with 76mm guns and HVAP ammunition, engaged German Panthers at ranges exceeding 1,000 meters and achieved penetrations. German tank commanders, accustomed to frontal immunity at these distances, discovered their armor was failing against hits that shouldn't be threatening. The psychological impact was immediate and devastating. Panthers that had survived dozens of engagements through protective value of their armor were being knocked out by single shots from tanks they'd been trained to consider inferior. The recurring symbol that came to represent VAP's psychological impact was a penetration hole itself. Specifically, the small, clean entrance wound that tungsten carbide penetrators left in Panther armor. Traditional armor-piercing rounds, when they achieved penetration, typically created irregular holes with significant cracking and spalling of the surrounding armor. The tungsten penetrator, traveling at extreme velocity, punched neat holes approximately 30 millimeters in diameter through armor plate, often leaving the surrounding metal relatively intact. German tank crews who inspected disabled Panthers began to recognize these distinctive penetrations, understanding viscerally that they represented a new threat. Photographs from the Ericourt battlefield, taken by American intelligence officers assessing knocked-out German armor, show Panthers with these characteristic holes punched through glassy plates and turret faces, plates that were supposed to be proof against frontal engagement. German salvage crews, attempting to recover damaged tanks for repair, found themselves examining vehicles that had been defeated by a weapon they hadn't known existed. The clean punctures became physical evidence that the tactical assumptions underpinning Panther doctrine were no longer valid. Tank crews began discussing these penetrations with the superstitious attention soldiers give to omens. The holes were too small to have been caused by the heavy American tank destroyer guns, 76mm and 90mm weapons that German crews knew and respected. They were too precisely circular to be glancing hits or lucky shots striking weak points. They appeared on frontal armor that was supposed to be invulnerable, and they were appearing with increasing frequency as September turned October and American HVAP production ramped up. For German tank commanders, the penetration holes represented the collapse of technological advantage. The Panther had been designed specifically to dominate medium-range tank engagements through armor and gun superiority. Its entire tactical doctrine assumed that German tanks could engage American armor from ranges where return fire was ineffective. The HVAP penetration holes, appearing on vehicles struck at ranges exceeding 1,000 meters, were physical proof that this assumption no longer held. They were holes punched not just in steel, but in the doctrinal certainty that it made defensive armored warfare psychologically sustainable for outnumbered German crews. Oberfeldwebel Karlbrenner, who survived the September 12th engagement with burns and shrapnel wounds, was interviewed after capture in October 1944. His description of seeing the penetration hole in his Panther's glassy plate revealed the psychological dimension. "I climbed out of the tank after my crew was hit. I walked around to the front to see where we'd been struck. There was a hole, a perfectly round hole through armor that I trusted to keep me alive. I put my fist through that hole. I could see daylight on the other side. And I understood that everything I'd been taught about Panther armor was no longer true. If armor means nothing, if Americans can penetrate frontally at ranges where we thought we were safe, then what are we? Just targets. Just men waiting to be killed in boxes that can't protect us anymore." This existential recognition that the protective envelope of armor had been breached by American technological innovation spread through German tank units faster than formal intelligence reports. Crews talked. Survivors described their experiences. Men saw the distinctive penetration holes on knocked-out Panthers being recovered from battlefields, and the understanding grew that American Shermans, which had been considered inferior and survivable threats, had been transformed into capable killers that could defeat Panther armor frontally at combat ranges. The psychological impact manifested in measurable ways. German tank crews began reporting mechanical problems more frequently, seeking reasons to avoid action. Instances of premature displacement, abandoning positions before situations became untenable, increased. Some crews, after achieving initial hits on American tanks that failed to penetrate, would disengage rather than continue fighting, fearing that the American return fire would be fatal. These weren't acts of cowardice. They were rational responses from men who had learned that their survival advantages had been neutralized, and that continuing to fight using doctrine designed for a different tactical reality meant accepting unacceptable risks. The American development and deployment of HVAP represented a characteristically pragmatic approach to military problems. Faced with German armor superiority, American ordnance engineers didn't attempt to completely redesign American tanks. That would have required years and would have disrupted production of the reliable Sherman platform. Instead, they improved the ammunition, creating a projectile that allowed existing tanks to defeat targets they couldn't previously threaten. It was innovation at the margin, the application of metallurgy and ballistics to solve a specific tactical problem without requiring wholesale changes to doctrine or equipment. This incremental improvement philosophy, make what you have work better rather than waiting for perfect solutions, was distinctly American in character. German weapon development in the same period pursued revolutionary designs. The Tiger II heavy tank, the Panther II, various paper Panzer projects that promised overwhelming superiority. These programs consumed resources and engineering effort while producing limited numbers of vehicles, many of which suffered from mechanical unreliability due to rush development. American ordnance focused on making the adequate Sherman more capable through improved ammunition, better armor configurations, and incremental upgrades, an approach that prioritized fielding improvements quickly over pursuing perfection slowly. The tungsten shortage that limited HVAP production was itself addressed through characteristic American industrial problem-solving. Ordnance departments worked with mining companies to increase domestic tungsten ore production. Recycling programs recovered tungsten from worn-out machine tools. Alternative alloys were developed to reduce tungsten content in industrial applications, freeing more material for military use. By late 1944, HVAP production had increased to the point where it could be issued more liberally, not unlimited, but sufficient that tank crews could expect to have HVAP available when facing German heavy armor, rather than treating it as a rare commodity to be hoarded. German tank crews, when they learned that American ammunition improvement was behind their armor's failure, reacted with a mixture of grudging respect and bitter resignation. They understood metallurgy and engineering. German industry had pioneered tungsten core ammunition early in the war. But Germany's strategic situation made tungsten increasingly scarce as access to foreign or sources was cut off. The same material scarcity that forced German tanks to use steel core ammunition meant that Germany couldn't effectively counter American tungsten core penetrators with equivalent ammunition. It was industrial capacity manifesting as tactical advantage. Americans had access to tungsten and the manufacturing infrastructure to produce HVAP in useful quantities, while Germans understood the principle but lacked the resources to implement at scale. This pattern, Americans solving tactical problems through industrial and material advantages rather than through tactical brilliance, was familiar to Wehrmacht veterans but remained psychologically difficult to accept. German military culture valorized skill, training, and tactical excellence. The idea that a better-trained, more experienced tank crew could be defeated by an inferior crew equipped with superior ammunition felt like a violation of how warfare should work. It suggested that material advantages trumped human excellence, that industry mattered more than valor, that America's wealth in strategic materials would ultimately decide outcomes regardless of German skill or determination. Captured German tank officers expressed this frustration repeatedly in POW interrogations. Hauptmann Ludwig Becker, a Panther Company commander captured in November 1944, articulated it. "You Americans don't fight, you manufacture. You don't outfight us, you outproduce us. You don't need better soldiers, you just need more tungsten." It's not warfare, it's industrial process. And we cannot compete with your industry, so we lose. Not because you're better, but because you have more. Is that supposed to be satisfying? Losing because the enemy has access to better materials. The American response, when articulated at all, was pragmatic. War is about winning, not about demonstrating superiority through handicap. If tungsten core ammunition provided an advantage, then use tungsten core ammunition. If industrial capacity allowed production at scale, then produce at scale. The point wasn't give the enemy a fair fight. The point was to win efficiently while minimizing American casualties. HVAP accomplished that by allowing American tanks to engage German armor on more equal terms, reducing the tactical advantage German crews had exploited for months. The tactical evolution of Sherman employment post-HVAP reflected the changed engagement dynamics. Prior to HVAP availability, American armor doctrine emphasized flanking maneuvers, accepting that frontal engagements with German heavy armor were to be avoided. Sherman units would use mobility and numerical advantage to get side shots on Panthers and Tigers, accepting casualties in the approach phase because frontal engagement was suicide. This doctrine was sound given ammunition limitations, but it meant accepting high loss rates and ceding the initiative to German armor that could dictate engagement terms from defensive positions. With HVAP, American armor could challenge German tanks frontally at medium ranges, not with certainty of victory, but with viable probability of achieving kills before being destroyed themselves. This changed tactical calculations significantly. Sherman units could now engage Panthers from hull-down positions at ranges where both sides could threaten each other, turning armored combat into a more balanced exchange where factors like crew training, gun-laying speed, and tactical positioning mattered as much as raw ballistic advantage. American tankers described the transformation in engagement psychology. Sergeant Robert Chun, a Sherman tank commander with the 4th Armored Division, recorded in a letter home in October 1944, "We got the new ammunition in September. Nobody told us much about it, except that it would penetrate Kraut-heavy armor if we hit them right. First time I used it, we were engaging a Panther at about 1,000 yards. I was ready to start flanking, because normally you can't hurt a Panther from the front at that range. But I had 3 HVAP rounds loaded, so I told my gun to take the shot. He hit the Panther on the glacis, dead center, and it stopped moving. Just stopped, like someone had turned off a switch. We couldn't believe it. We'd killed a Panther from the front at 1,000 yards with a Sherman. Changed how we thought about engaging German armor completely." Robert's experience was replicated across American armored units as HVAP became more available. Tank crews gained confidence that they could hurt Panthers frontally, which made them more willing to engage rather than maneuver. This didn't eliminate the need for flanking tactics or combined arms coordination, but it meant American armor wasn't automatically disadvantaged in frontal engagements. The psychological shift mirrored the German experience in reverse. Where German crews lost confidence in their protective advantage, American crews gained confidence in their offensive capability. The statistical impact appeared in engagement outcomes through autumn 1944. Analysis of tank battles in Lorraine, the Saar, and later in the Ardennes during the Battle of the Bulge showed improving American kill-loss ratios against German armor. Where early engagements might see Americans losing 3 or 4 Shermans for each Panther destroyed, later battles approached 1-to-1 exchanges or even favorable ratios when American numerical and tactical advantages were fully leveraged. Not all of this improvement was due to HVAP, American crew experience, better coordination with artillery and air support, and German logistical degradation all contributed. But VAP's availability removed the automatic German advantage in frontal engagements that had been the foundation of their defensive armor tactics. For German tank crews, the experience of fighting through late 1944 and into 1945 became increasingly surreal. They manned tanks that were technically superior to their opponents. Panthers still had better guns, better optics, and thicker armor than Shermans. But technical superiority no longer translated to tactical dominance because American ammunition had neutralized enough of the armor advantage to make engagement survivable for American crews. And with Americans holding overwhelming numerical superiority, German panzer divisions by late 1944 were typically at 30 to 40% of authorized strength, while American armor divisions remained near full strength. The loss of qualitative edge meant losing the one advantage that had kept German armor relevant. The progression of disillusionment followed a consistent pattern across German tank units. First came confusion, when armor failed against hits that shouldn't penetrate. Then came recognition that American ammunition had improved. Then came attempts to adapt doctrine, engaging at longer ranges, seeking more cover, becoming more conservative in tactical employment. Finally came fatalistic acceptance that no adaptation would restore the decisive advantage, that every engagement risked destruction regardless of crew skill or tactical correctness, and that survival was increasingly a matter of luck rather than competence. Hans Kruger, a Panther driver who survived until war's end, described this progression in a 1979 interview. You could feel the morale changing month by month. In Normandy, if we saw Shermans, we were confident we could kill them before they could hurt us. By September, after we started seeing Panthers knocked out frontally, we became cautious. By November, we were scared. Not cowardly scared, but rationally scared. We understood that our armor didn't protect us anymore, that Americans had found a way to kill us at ranges we'd thought were safe. By December, during the Ardennes offensive, we were just going through motions, following orders because we were soldiers, but not believing we'd survive. You can't fight effectively when you don't believe your equipment will protect you. The psychological collapse of confidence in German armor's protective value was, in many ways, more damaging than the physical destruction of tanks. Weapon systems depend on crew confidence, the belief that if you perform correctly, your equipment will keep you alive. Remove that belief, and crews become tentative, defensive, prone to abandoning vehicles at first sign of damage rather than fighting through adverse situations. The transformation of the Panther from an invulnerable fortress to a vulnerable platform happened in the minds of German crews before it happened on battlefields, driven by the accumulation of evidence that HVAP rounds could defeat their armor with increasing regularity. German attempts to counter HVAP were limited by industrial capacity. In theory, adding additional armor plates to Panther glacis plates or turret faces could defeat HVAP penetration. In practice, German industry lacked the production capacity to retrofit existing Panthers or to manufacture new vehicles with enhanced armor without reducing production numbers. Some field modifications were attempted, welding additional armor plates to vulnerable areas, but these added weight that Panther transmissions and suspension couldn't reliably handle, leading to increased mechanical failures. The fundamental problem was that Germany's industrial situation in late 1944 precluded the kind of rapid iterative improvement that American industry could achieve. The Panther had been designed in 1942, when American armored doctrine still relied on 75mm guns, and when tungsten core ammunition wasn't widely deployed. By late 1944, the tactical environment had changed, but German industry couldn't rapidly redesign and remanufacture armor to match new threats. The Panther remained a formidable vehicle when properly employed by skilled crews, but it was no longer the decisive weapon that could reliably dominate armored engagements through technical superiority alone. And for German tankers who relied on that superiority for survival, the change was psychologically devastating. The Battle of the Bulge in December 1944 provided a final, tragic demonstration of VAP's impact on German armored operations. Germany's last major offensive in the West committed the cream of remaining panzer forces, including elite SS panzer divisions, in an attempt to split Allied armies and recapture Antwerp. Initial German advances benefited from surprise, poor weather that limited Allied air power, and terrain that channeled American forces into defensive positions. But as American armor reinforcements arrived and weather cleared, German tank units found themselves engaging American Shermans that could threaten Panthers and even Tiger II's frontally with HVAP ammunition. The engagement at Elsenborn Ridge on December 17 to 18, 1944 exemplified the changed dynamics. German armor from the 12th SS Panzer Division attempted to break through American positions held by elements of the 2nd and 99th Infantry Divisions, supported by Sherman tanks from attached tank battalions. German commanders expected their Panthers and Tiger IIs to dominate American armor, creating breakthrough opportunities for infantry exploitation. Instead, American Shermans equipped with HVAP engaged German heavy armor at medium ranges, 800 to 1,200 meters, and achieved multiple kills. German attacks stalled not because they were outnumbered, but because their armor couldn't achieve the decisive superiority needed to break prepared American positions. Post-battle analysis by German commanders revealed frustration and incomprehension. Oberst Otto Skorzeny, whose brigade participated in the offensive, noted in post-war interrogation, "We expected our armor to dominate. We had Panthers, we had Tiger IIs, we had veteran crews. The Americans had Shermans, inferior tanks that we've been destroying for months. But they killed our tanks, not by flanking, not by superior numbers in immediate engagements, but frontally, at ranges where we thought we were invulnerable. It was demoralizing for the crews. Men who'd fought at Kursk and Normandy suddenly weren't sure their tanks could protect them." The collapse of German offensive momentum in the Bulge had multiple causes: fuel shortages, American air superiority once weather cleared, overwhelming Allied numerical advantage, German logistical fragility. But the failure of German armor to achieve decisive tactical victories in individual engagements was central to the offensive stalling. Panthers and Tigers that should have been force multipliers, breaking American lines through superior firepower and armor, were being fought to tactical stalemate by American Shermans that could finally threaten them frontally. HVAP didn't win the Battle of the Bulge, but it prevented German armor from winning it, which amounted to the same thing: the symbolic weight of HVAP penetrations. Those small, clean holes punched through supposedly invulnerable armor extended beyond their tactical impact into how German tank crews understood their war's trajectory. Each penetration was physical evidence that American industrial capacity could overcome German technical excellence. Each hole demonstrated that material advantages would eventually trump tactical skill. Each punctured glacis plate was a small monument to the truth that German soldiers had been resisting psychologically, that you cannot win a modern war against an enemy with overwhelming industrial superiority, no matter how brave your soldiers or superior your individual weapons. The holes also represented the democratization of armor-killing capability. Prior to HVAP, only specialized American vehicles, tank destroyers with 76mm or 90mm guns, and a few upgunned Shermans could reliably threaten German heavy armor frontally. HVAP allowed standard Shermans with 76mm guns to achieve the same results, multiplying the number of American vehicles that German armor had to respect. From a German perspective, this meant that every Sherman was potentially lethal, that nowhere on the battlefield could Panthers position themselves without risk of frontal engagement by American tanks that could penetrate their armor. This proliferation of threat, from facing a few specialized vehicles to facing an entire army of tanks capable of killing you, fundamentally altered German tactical calculations. It wasn't sustainable to treat every Sherman as a potential killer, because that would mean treating the entire American army as an immediate threat, which would paralyze operations entirely. But it also wasn't safe to dismiss Shermans as inferior targets, because any given Sherman might be carrying HVAP and could kill your Panther frontally before you destroyed it. German tank commanders found themselves in an impossible position. They couldn't afford to be cautious about every engagement, but they couldn't afford to be aggressive either, because American ammunition had eliminated their margin for tactical error. The tungsten that made HVAP possible became, in German understanding, the symbol of American abundance. Germans knew about tungsten core ammunition. They'd pioneered it. But they couldn't produce it in relevant quantities because tungsten was scarce in German-controlled territories. Americans had access to tungsten from Western Hemisphere sources, had the shipping capacity to transport it, had the industrial infrastructure to manufacture ammunition at scale. The penetration holes were made possible by access to strategic materials that Germany lacked, giving physical form to material disparity that underlay Germany's strategic defeat. Captured German officers, discussing HVAP in POW camps, often fixated on this material dimension. They could accept being outfought. There was honor in losing to a better soldier. They struggled to accept being outmaterialed, losing because the enemy had access to tungsten, while Germany didn't feel like being defeated by geology rather than by human agency. Lieutenant Heinrich Stoltz, the Panther commander whose tank had been penetrated at Ericourt, expressed it. "We lost because you had tungsten and we didn't." That's humiliating. Not because it questions our courage, we fought bravely. It questions whether any of it mattered, whether skill or training or dedication mean anything when the enemy can simply outspend you in strategic materials. Is that warfare? Or is that just industrial competition where the side with more resources wins automatically? The American answer, insofar as one was articulated, remained pragmatic. Warfare is industrial competition, at least in part. Strategic materials matter. Industrial capacity matters. A nation that can field better ammunition defeats a nation that cannot, all else being equal. There was no apologizing for tungsten availability or HVAP effectiveness. These were advantages that America possessed and Germany lacked. And exploiting advantages was how wars were won. By early 1945, as Allied armies closed on Germany's borders, Panther tanks remained formidable weapons in capable hands. Their guns could still kill American tanks at long range. Their armor, despite VAP's effectiveness, still provided substantial protection against most American ammunition types. But the psychological edge, the confidence that had made Panther crews aggressive and effective, was gone. German tankers no longer trusted their armor to keep them alive. They no longer believed they possessed decisive tactical advantages. They fought defensively, cautiously, without the conviction that had characterized German armor operations earlier in the war. The transformation was visible in tactical behavior. Panthers that should have been counterattacking American penetrations instead sat in defensive positions, firing sporadically, retreating at first sign of being flanked. Crews abandoned tanks after minor damage, unwilling to fight through mechanical problems or ammunition shortages because they no longer believed survival was likely regardless. German armor, which had been a fire brigade that rushed to crisis points to restore situations through violent counterattacks, became a static asset, dangerous when Americans attacked into its fields of fire, but increasingly unable to take initiative or restore German defensive cohesion through offensive action. American intelligence officers noted this transformation in German armor doctrine through late 1944 and early 1945. Reports consistently described German armor as defensive and reluctant to engage at close range. What American observers interpreted as doctrinal change was actually psychological collapse, the cumulative effect of months of fighting an enemy that had neutralized German technological advantages through industrial and material superiority. The final irony was that by early 1945, HVAP shortages reemerged due to competing tungsten demands across all American military services. Sherman crews sometimes found themselves with limited HVAP allocation again, forced to conserve rounds for critical engagements. But the damage to German armor morale was permanent. The knowledge that Americans possessed ammunition capable of defeating Panther armor frontally remained in German tankers' minds regardless of how many HVAP rounds were actually available at any given time. The possibility of facing HVAP was sufficient to undermine confidence, even when individual engagements might not involve HVAP at all. German tank crews fought through until war's end, performing their duties with professionalism that characterized the Wehrmacht even in defeat. But they fought without illusions, without hope, without the confidence that had sustained them through earlier battles. They knew their tanks could be penetrated. They knew American ammunition had closed a technological gap. They knew that survival was increasingly unlikely regardless of skill or adherence to doctrine. And they fought anyway, because surrender wasn't acceptable, and retreat only delayed inevitable defeat, and there was nothing left but to keep fighting until fighting became impossible. May 8, 1945. The war in Europe ends. Across Germany, thousands of Panther tanks sat abandoned, some destroyed in combat, many others simply left by crews who'd run out of fuel, ammunition, or will to continue. American ordnance teams examining these vehicles found examples of HVAP penetrations. The distinctive small diameter holes punched through frontal armor that shouldn't have failed. Metallurgists studied the penetration signatures, measuring hole dimensions, examining the fracture patterns in armor steel, documenting the effectiveness of tungsten carbide penetrators against sloped armor plate. The studies confirmed what battlefield reports had already established. HVAP had been remarkably effective against Panther armor when it hit. The tungsten core's density and hardness, combined with high impact velocity, allowed penetration of armor that defeated conventional steel projectiles. The engineering was sound, the metallurgy was correct, and the tactical results justified the program despite tungsten scarcity that had limited production. But the more significant impact wasn't measurable in metallurgy labs or ballistics tests. It was recorded in the psychological dissolution of German armor crews' confidence, in the transformation of the Panther from invulnerable fortress to vulnerable platform, in the recognition that American industrial capacity could respond to German tactical advantages with technological innovations that neutralized those advantages faster than German industry could counter them. The small round holes punched through Panther armor plates became historical artifacts, physical evidence of a technological race where American material abundance had overcome German engineering excellence. They represented the application of strategic materials to tactical problems, the transformation of industrial capacity into battlefield advantage, the demonstration that in modern war between industrialized nations, control of resources and manufacturing capacity matters more than individual weapon superiority. For the German tank crews who trusted their Panther's armor and discovered that trust was misplaced, the penetration holes represented something more personal: betrayal. Not betrayal by their commanders or their nation, but betrayal by the promises implicit in their equipment. The Panther was supposed to protect them. Its armor was supposed to keep them alive while they killed enemy tanks from safe distances. When HVAP rounds punched through that armor, they weren't just punching through steel. They were destroying the psychological contract that made armored warfare survivable for outnumbered German crews. The tungsten carbide cores that created those holes, recovered from knocked-out Panthers and studied by German engineers after the war, became object of fascination. They were small, dense, unremarkable in appearance, but they represented American access to strategic materials that Germany lacked, American manufacturing capacity that Germany couldn't match, American willingness to apply industrial resources to tactical problems in ways that German war economy couldn't replicate. The cores were tiny monuments to material abundance as decisive advantage in industrial warfare. In the final accounting, HVAP didn't win the war. It was one factor among many: air superiority, logistical dominance, numerical advantage, industrial capacity, strategic material access, and countless others. But HVAP shortened the war by accelerating the defeat of German armor, by removing the tactical advantage that Panthers had enjoyed through mid-1944, by forcing German tank crews to fight without confidence in their equipment's protective value. It transformed Sherman tanks from vulnerable targets into viable threats, changing the calculus of armored warfare in ways that made German defensive operations more costly and less sustainable. The holes punched through Panther armor told a story larger than their small diameter suggested. They were punctuation marks in the narrative of Germany's defeat, physical proof that American innovation and industrial capacity could overcome German tactical excellence. They were evidence that in modern war, the side with more resources, better manufacturing, and access to strategic materials will eventually develop solutions to tactical problems faster than the other side can adapt. They were small, precise, lethal demonstrations that abundance is its own form of military power, that access to tungsten matters as much as crew training, and that in the competition between steel armor and tungsten penetrators, tungsten wins. And for Karl Brenner, lying in a POW camp hospital in October 1944, his burns healing slowly while he replayed the moment of penetration in his mind, that small round hole in his Panther's glassy plate represented the end of certainty. He had trusted his tank to protect him. It had failed. American engineers had found a way to defeat German armor, using materials Germans couldn't access in sufficient quantities. The equation had changed. The mathematics had been rewritten, and all his experience and training couldn't overcome the simple fact that Americans had tungsten and knew how to use it. The hole was just 30 millimeters across, but it had destroyed more than armor plate. It had destroyed the illusion that German technical superiority could compensate for American material advantages. It had demonstrated that industrial capacity would ultimately prevail over tactical skill, and it had shown with brutal precision that in the contest between German engineering and American abundance, abundance would find a way to win, not through superior skill or better tactics, but simply by applying enough resources to solve the problem, regardless of how many resources that required. That was a lesson written in tungsten and steel across the battlefields of France and Germany in 1944 to 45. That no armor is impenetrable if the enemy has sufficient industrial capacity to develop better ammunition. That no tactical advantage is permanent against an opponent who can outproduce and out-innovate you. And that confidence built on technical superiority becomes terror when that superiority is undermined by technological evolution you can't match. The small holes punched through Panther armor were windows into that truth, uncomfortable, undeniable, and ultimately decisive.